All right, so now that we're on chapter 2, okay, we're going to be looking at relations and functions, all right, domain, range, map, and diagrams, all right. So this section should be pretty simple, but it's going to be leading to us doing graphing, all right. You either love graphing or you don't. I think it's really easy, so hopefully you'll learn to love it. So, relation is a set of pairs of input and output values. You can write a relation as a set of ordered pairs. Guys, a relation is any set of ordered pairs. All right? If you have any set of ordered pairs, it is a relation no matter what. Now, a function is different, and we're going to learn the difference between the two. A function has rules to follow. So when they say graph each relation, okay, all we're going to be doing is plotting all these points. Oh. Who remembers how to plot points? All right, Alex.
If the front number is on the X line and the 4 is on the Y, I forget if it's.
So the first number is the X, and the second number is the Y.
Yeah.
Good. All right, so if I have -2 as my X value, I'm going to move over to -2. Okay. And then 4 is my Y value, I go up 4. 1, 2, 3, 4, and I plot a point. That is naming a point right there, just marking a point. Next is 3, -2. So I'm going to go to the center. I'm going to move over 3. 1, 2, 3. And then now I go down 2. 1, 2. I really do hope that most of you know how to do this. For the next one, it's -1, 0. You go at 0 again. You move to the left 1. And since it's 0, we don't move up or down. We stay there. And for the last one, it's 1, 5. So we go to the right 1 and then up 5. 1, 2, 3, 4, 5. That is all you're doing with these guys. If they want you to graph a relation, they just want you to plot the points. All right, it's meant so you guys learn how to plot points. Do the next 2 on your own. It should be very simple for you guys. All right. So for the first one, it's 0, 4. Ben, can you tell me how I plot 0, 4?
You stay at 0.
Okay.
4.
Up 4. 1, 2, 3, 4. Excellent. Very good. Now, if I wanted to plot -2, 3, how would I do that, Tristan? One, 2, 3. Okay. Excellent. -1, 3. Let's go, Brooke. Very good. And -2, 2. Alex. -2, 2.
Oh, you're talking to me.
There's only one Alex in this room.
Okay, you go over 2 to the left, and then up 2.
Good. And my last one, 1, -3, Mary.
Go to the right 1.
Okay.
And then you go down 3.
All right. So hopefully no one had any problems with that. I'm going to do the next one a little quicker. All right, so -2, 1, move over 2, go up 1. -1, 0, 0, 1, and 1, 2. Any questions on these?
Not really.
Pretty simple. Good. That is a relation. A relation is just a bunch of ordered pairs. Okay? Now, domain and range. Who knows what domain and range means when we talk about relations? Yes?
Isn't that when you do the bots and the stuff on the left side is all the X bots and then the stuff on anything on the right is the Y?
Okay, that is true. All right, so domain and range, we don't have to actually make the box. Okay? When it comes to domain and range, the domain is your X values and the range is your Y. So the first thing you're always going to want to do is find all your ordered pairs. So when we're looking at this, books and book bags, we want to find all of these ordered pairs and write them down before we decide what our domain and range is. So my first one, I'm going over 2 and up 4. That's one ordered pair. All right. Do we know how to find ordered pairs?
Mm-hmm.
All right, find the rest. Hmm?
It is.
All right, so hopefully we had these 2, 4, 3, comma 4.5, 4, comma 7.5, 5, comma 7, 6, comma 5, and then 6, comma 7.5. Now they want us to find a domain and range. So the domain gets labeled with a D, the range gets labeled with an R. And then it gets this cool little squiggle bracket, which I actually don't know the name of. Does anybody know the name of that?
Weird squiggly bracket.
Thank you for saying the same thing I did. All right, I'll have to look up that word later. You just start up. All right, so for the domain, you're going to label all the X values. Now you only label them once. So if there's like 6 4s, I only have to write 4 down once. So let's see. Now I usually like to write these in order. So I see a 2. The next highest value is a 3. The next highest value is a 4, 5, and then 6. So I listed all of the X values for a domain. Now the range. That's all the Y's. Again, I like to go in order. I think the lowest is 4. Then we get 4.5. And then 5. Then 7 and 7.5.
It was 5.
Right here. That's how we find a domain and range. You list all the coordinates first. All right, if you have to list the coordinates. Sometimes they'll just give them all to you. And then you find the X values and the Y. All right, next page, there's 2 of them. Knock them out on your own now. Should take you no time at all. right, so we should have had these listed as our ordered pairs. For the domain, who has all the domain values for B? Crystal?
-3, 0, 2, and 4.
Excellent. Who has all the range values for B? Hope?
-3, -1, 1. That's it, right? Oh, for that, sorry, I was on the other one.
Go ahead.
-3, 1, 2, and 4.
All right, good. And since you wanted to give me the other one, please give me the range of the other one.
-3, -1, and 1.
That's a domain, right?
Yeah.
Okay. And then also the range?
-4, -2, 1, and 3.
Excellent. All right. So we should have had problem. All right, any questions on this, guys? Should be pretty simple. All right. Everyone have a copy down before I move on? All right. Next, mapping diagrams. All right. Mapping diagrams pretty easy again. You need to have a relation, a bunch of ordered pairs. You're going to list your x values in one area and then your range in the other. And then we just connect the lines. Now, you never repeat a number. So for a mapping diagram, you label it domain and range. You list all of your x values. I always like to list them in order again. So it's going to be -5, -1, and 3. And you only write each number once. You don't write it more than once. And then for the range, -10, -2, 2, and 6. Okay, mapping diagram. Yeah.
Is this the one where you put the line towards which
Yeah.
one it matches? Oh, okay.
So now we're going to draw lines connecting the spots. Okay. So -1 goes to -2. 3 goes to 6. -5 goes to -10. And 3 goes to 2. Now, from a mapping diagram, the reason why we do it is it makes it easier for kids to understand what makes a relation a function or not. Now, we didn't learn about functions yet because that's probably on the next page. But who can take a guess if this is a function or not? Yeah.
It is not a function
Good. Why not?
because 3 goes into 2 different.
Good.
I mean,
If a domain value has more than one line coming off of it, it is not a function. So we're going to write next to this guy, not a function. Again, we'll be learning about that on the next page. All right? Do the next two on your own. Make sure you label one domain, one range, and then list all the points. I'll leave this up here as long as I can. What? Eventually. Yes.
I had a question of like if it's a function or not.
Okay.
If like say for number or for B, if it was like 0, 2, 1, 3, 2, 4, and then another 0, 2, would that still be a function or no? No.
No. Good question though. I mean, usually you never see that, to be honest. That they'll say the same number twice, but it's not a function. Yeah.
Is it like easy
I don't know if
to-
that could happen, to be honest. Get the same number. No, you wouldn't do that ever, plotting points. So that's probably why you never see that case. Okay, yeah. Sorry, Julian, what was that?
Like, wouldn't it be easy to figure out if it's not a function if there's more numbers on the range side than there's on the main side?
You mean different numbers?
No, like there's more numbers. Like on the other one, there's 3, and on the range there's 4.
I mean, yeah, that's going to be your way of telling for sure. All right, domain 0, 1, 2, range 2, 3, 4. 0 goes to 2, 1 goes to 3, 2 goes to 4. All right, and that is a function. All right. Savannah, can you tell me what you did for the domain for this one? All the values you need to put down?
-2,
-2,
-1,
-1,
0,
0.
and 2.
Excellent. And the range?
3,
3,
5,
5,
and 8.
and 8. All right, so be careful. I mean, well, this is not going to be a function, but still. All right. So we connect all the dots. 2 goes to 8. -1 goes to 5. 0 goes to 8. -1 goes to 3. And -2 goes to 3. Is this a function or not?
No.
Not a function. Okay. Because of the -1. Not a function. All right, easy stuff. All right, let's move on. All right, let's talk about what makes something a function. Okay. Right now, looking at mapping diagrams, what makes something a function, again, is if none of our domain values repeat themselves. So we have 3 mapping diagrams we're looking at, and you have to decide if it's a function or not. So our attention is always a focus on the domain. Please write down if you think they're a function or not. Bless you. I'll give you guys just a few moments. Write down function or not a function. Everybody, please do this now. All right. For A, what do you guys say?
Not a function.
Why, Julian?
Just to maybe 2 goes twice.
Good. So not a function. All right, next one. Function. Why?
Because none of the domain is shown.
Excellent. And last one.
Function.
Good. All right, let's continue from here. The next thing we learn about is something called a vertical line test. All right, I find this to be extremely easy. All this is saying that if we have a graph of pairs or lines graphed, like we have here, if you do a vertical line anywhere on this graph and you see that it hits 2 points that were graphed, it is not a function. All right, so no matter where I draw a line, it has to always hit 1 point. Now, I don't ever draw a line, but what I do is I'll take my pencil and I'll be like, all right, so if I did a line here, would I hit 2 points on the graph?
Yeah.
Yeah, I'm hitting right here and here. Because I'm hitting 2 points, that means it's not a function. That is the vertical line test.
But so Mr. Fine, what if it doesn't, like, it hits 2 points on, like, some parts of the graph?
If it hits 2 points at all, it is not a function. Even if it's on one part. Okay?
Yeah.
So, let's look at this one. If I do a vertical line up and down all the way through this entire graph, does it ever hit 2 points?
No.
That is a function. All right? This is the vertical line test. Very easy. It's a vertical line to test if something's a function or not. And for the next one, is there any place where I hit that I'll hit 2 points?
Yes.
Yes.
Not a function. Okay? Nice and easy. All right. Let's get to stuff that actually involves us doing a little bit of work. All right, f of x. So the function notation, f of x. All right, you see the f and then the x in the parentheses. All right, that means it's a function of f of x. So you're focusing on that x. Notice that f of x does not mean f times x. When the value of x is 3, it's f of 3. All right, that means anywhere there's an x, we're going to be plugging 3 into it. That is what that actually says. F of 3 represents the value of the function at x equals 3. Okay, so f of x, you see how it says x here? You'll see that this variable here will always be like x. And that's where we're always going to plug whatever number is here into all the values on this side. All right, this does not get moved over or divide. It's just saying that, hey, we plugged in 3 here to get our answer that we're going to get over here. Okay, that's all that it's saying. It's letting us know what we plugged in to get the answer we get. All right. So, the area of a square tile is a function of the length of the side of a square. The area of a square tile is a function of the length of the side of a square. Write a function rule for the area of a square. Evaluate the function for a square tile with side length 3.5. So, it says is a function of the length of the side of a square. So when I see that, f of s, function of side of square. Does anybody know the equation for area of a square? Yeah.
Isn't it 3 1/2 and then 4?
I think you're thinking of like volume of a sphere or something like that. Yeah. Basically, but since it's a square, it's just going to be the sides squared. The side times the side. It's the same thing. But length times width is absolutely right. These variables are the same. Now, saying that the side is 3.5. So what that means is I'm going to be plugging in f of 3.5. This 3.5 just gets plugged in for s. And then the function at 3.5 equals 12.25 inches squared. So what this lets us know is if we had a bunch of solutions, I would know, hey, the function at 3.5 equaled this. So then I can do another one. The function at 4 equals this. And I know what value I plugged in to get my answer. This does not get moved over. It stays there. All right? It is letting you know what we plugged in. Do not divide it to both sides, please. All right. Now, this is why we do the function, the f of a letter. So they want us to be plugging in -3, 0, and 5 for each function. So this will take up a little bit of space. So what that means is I'm going to be plugging -3 in for the x and then solving for what happens. So f of -3 equals 3 times -3 minus 5. Bless you. I'm going to plug that in my calculator, and I get f of -3 equals -14. Now, if I know this answer, I already know that I plugged -3 in to get that answer. Because now they also want me to plug in 0. 3 times 0 minus 5. The function at 0 equals -5. And last but not least, the function at 5 equals 3 times 5 minus 5. The function at 5 equals 10. Again, the reason why this is so great is because if I wasn't looking at all the work and I just saw this, I would know that when I plugged in 5, I got that answer. That's what that lets us know. When you plugged in 5 into the function, you got 10, and so on and so forth. So you wouldn't have to have all this work and everything written out because it already lets you know exactly what happened. Obviously, you guys are going to have to show all your work, but the reason why we do it is to make things nice, neat, and organized. All right, do the next one. Yeah. I mean, you probably missing it through something. Probably not. Do it on your own. Don't copy what I wrote down.
Yeah, do it on my own.
Okay. All right. Let's see how we did. So when we plugged in -3, what did we get? Alex?
Oh yeah, for that one, I got. Wait, which one did I say? I got -13 over 4.
All right, -13/4.
I rounded it and then did that.
Let's leave it like that. When we plug in 0, that one's really easy. You get -1. Huh? You got 11/4? Oh, the next one. The next one is 11/4. And the last set. Plug in -3. What do we get? No. Stop. What do we get?
-6 over 5.
What do we get?
6 over 5.
6/5.
I don't know why I said that.
All right, next one's really easy since we're plugging in 0. Just 3/5. And the last one. It should be negative 2/5. All right. Any questions? Your homework is a practice 2-1. The entire sheet.
In the back.
No, just 2-1.
Oh.